Alright, let's look at number 1. Okay, if objects A and B are both made out of gold, which of the following statements is not true? Well, the answer in this case is that B has a greater density than A, because if they're both made of gold, then what we'll find is all gold has a density of 19.3 grams per milliliter. And so they both have to have the same density, so therefore B cannot be true. Let's look at 2. If objects A and B are both have the same mass, so they have the same mass as each other, which of the following statements could be true? Well, in this case, the answer is going to be that A is made of a denser material than B. And the reason is it's more compact. So what we find is that B has the same mass, but it occupies more space. So if I took this much mass and compressed it down into a smaller volume, I'd have A, so it would have a higher density. Let's look at question number 3 here. Alright, now in this case I'm going to have to use the density equation. So the density equation is density equals mass over volume. You need to know that, and you also have to know this, that mass is going to be measured in grams, and that volume is going to be measured in milliliters. So let's just look at the first one here. It says if an object has a volume of this and a mass of this, which material is it made out of from this list up here? So in this case what we're going to do is we're going to say density equals, now we have to use our units. You've got to train yourself to use the units. So here's milliliters. Milliliters are volume. Volume goes here, so I'm going to put the volume down below. 19.68 milliliters. And here I have, it says a mass of, well that helps me because mass goes up above. So therefore I'm going to put 176.3 grams, that's a 0.3 grams up above. And when I divide the top by the bottom, what I'm going to get is, let me get my calculator, I'll get 8.958, and that will be grams per milliliter. In other words, 8.98 grams of matter fit in every milliliter of space. And if I look up above, well, that looks like it must be copper. So I'm going to say it is copper. Let's look at number 4. On number 4, the question is, and here's how I like to approach this. I like to say, find the word that makes it a question. What? What is the mass? So I know this is what I'm trying to solve for. So this is the variable that I'm going to leave as a letter. So if the equation is D equals M over V, I'm solving for the M. So I should know what the D is. It says a quartz crystal. So if I go up here and find quartz, a quartz crystal has a density of 2.61 grams per milliliter. So I'm going to say 2.61 equals, I'm going to leave the units off while I'm doing the math, mass divided by, in this case the volume is 49.2 milliliters. Now here's how Samson does math. I say, look, here's my variable. I need to be able to say M equals something. Right now M is being divided by 49.2. So the opposite of dividing is multiplying. I'm going to multiply both sides by 49.2. That's a 49. And then when I do that, what I'll get is M equals 128 grams. Now there's another technique I could show you, alright? It's called the equation circle. The equation circle goes like this. You draw a circle, you draw the equator, you chop the south in half. If you have a 3-variable equation like what we have here, 1, 2, 3, it's perfect for this. So there is a fraction line here, this is a fraction line. Whatever is in the numerator is going to go up above, and the other 2 variables go down below. So if I want to use the equation circle to solve number 4, what I would say is, it says, what is the mass? So I'm going to cover up mass. And if I cover up mass, what I see is, it tells me I had to say density times volume. If I cover up the density, it would be saying mass divided by volume, and if I cover up the volume, it would say mass divided by density. So in this case, since I'm looking for mass, that would say, look, take the density value and multiply it by the volume, which is exactly what we did. So let's try using the equation circle to answer the next one. What is the volume of? Okay, so if I was to cover up volume, that would say, take the mass and divide it by the density. So let's just try this. I'm going to take the mass, which is 145.2 grams, and divide it by the density, in this case of lead. So if I look up above, the density of lead is 11.35. So I'm going to divide by 11.35. And when I do that, what I'm going to get is 12.80 milliliters. Okay, let's go on here. Number 6. Let's make it a little bit bigger. Alright, which takes up more space? Okay, so space, if you recall, is volume. So I'm looking for volume. And if I use the equation circle, the equation circle is density equals mass over volume. And I'm looking for space, which is volume. So if I cover up volume, that says take the mass and divide it by the density. So I'm going to take, in this case, the mass of iron is 26.9 grams, and I'm going to divide that by the density of iron, which is, the density of iron is right here, 7.87. So let's come back down here. I'm going to divide it by 7.87, and when I do that, that's going to give me 3.41 milliliters, because I'm looking for space. And then I'm going to do the same thing for the iron. So again, I'm looking for the volume. So if I cover up volume, that tells me take the mass and divide it by the density. So the mass is 26.7 grams of copper divided by the density of copper, which I'm going to cheat. It's right here. It's 8.95. 8.95. And what that gives me is 2.98. 2.98 milliliters. So in this case, the question is, which takes up more space? Which takes up more space is the iron. Let's look at the next one. How big? Big is volume. Let's do it not using the equation circle this time. So I'm going to say density equals mass over volume. I've got aluminum, so let's figure out what is the density of aluminum. The density of aluminum, according to this, is 2.7 grams per milliliter. 2.7 grams per milliliter is my density, 2.7. That equals the mass, which is 38 grams over the volume. Now, you know, in math class it might have taught you a couple ways of solving this, but here's the thing. When you're trying to solve for a variable in the denominator, I wanted to set off alarms. Whoop, 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 whoop. You got a variable in the denominator. You know what you do when that happens? You do the swap. You're going to swap the variable in the denominator for the number on the other side here. It works every time. So I'm going to swap these two, and what that gives me is V equals 38 over 2.7. By the way, I could have got that using the equation circle, because if I'm looking for volume, it says take the mass, which is here, and divide it by the density, which is here. So either way it works. What I find when I do this is that the volume in this case is 14 milliliters. Alright, let's try what number 8 is. Let's move up and look at number 8. Alright, let's see. Was the chain made of gold? So in other words, I have to know what the density is. And so this is getting down to, do you know how to calculate the density of an object based on these variables here? Well, so I know to find density, I have to say density equals mass over volume. I know what what the mass is in this case. It's 146.7 grams. I have to find out what the volume is. Well, look what happened here. Let's see, I'm going to move this over. According to this, I had a volume that was 60 milliliters. It went up to 60.87. So therefore, the difference in these two values is because I put the gold chain in there. And so the difference between those two is 8.7 milliliters. And so if I divide those two numbers, what I'm going to come up with is 16.86. 16.86 grams per milliliter. Is that gold? Well, let's just see what the density of gold is. The density of gold, it turns out, is actually 19.3. So this chain is not dense enough to be gold. It's dense, but it's not dense enough to be gold, so the answer is going to be not gold. Give me back my money. Alright, and let's look at the last one here. Look at the data below. Which planet has a greater density, Earth or Jupiter? I guess this isn't the last one. Well, you know what? This is just calculating density using scientific notation. So really the question is, can you solve the density equation using scientific notation? So let's do Earth first. D of Earth. D of Earth is going to equal, let me just move us over a little bit here. D of Earth is going to equal 5.98 e to the 27th divided by 1.1 e to the 27th. And what that gives me is, let me look it up here, for Earth, I get 5.4 grams per milliliter. Now let's do the same thing for Jupiter. For Jupiter, I take its mass, so let's do DJ. Density of Jupiter, why did I make it lowercase, I don't know. Alright, it's going to be 1.89 e to the 30th. That's a terrible 30. That's even worse now, it looks like a B. Divided by 1.39 e to the 30th. And what that gives me is, what's that? Gives me 1.36 grams per milliliter. So it turns out that Earth, by far, has a greater density. That's because Jupiter is a gas planet. Come on. Alright, let's look at the next one. Alright, let's string this down a little bit here. A sample of iron has the same mass as a 42 piece of lead. What is the volume of the iron sample? Ooh, I like this question. So what I got to do first is I've got to find the mass of the lead. So what I'm going to do is I'm going to use D equals mass over volume, and I want to figure out what is the mass of the lead. So let's try now. Lead has a density of, I'm going to have to look it up. Density of lead, I think 11.3, 11.35. Okay. So I'm going to say 11.35 grams per milliliter equals the mass over 42 mLs. And when I solve that, I'm going to have to undo what's being done to m. It's being we're being divided by 42, so I had to multiply both sides by 42. So if I multiply both sides by 42, what I get is the mass equals 11.35 times 42, and that equals, the mass equals, hang on a second, let me calculate real quick. It equals 476.7 grams. Now what I want to do is I want to use this value here to find the volume of the iron sample. So now I'm looking for volume. So we got, again, we had to know the density of iron. I think it's 7 point something. The density of iron, 7.87. Okay, 7.87. So now what I'm going to do is I'm going to say density equals mass over volume. And I know the density of iron is 7.87 grams per milliliter. I know the mass is 476.7 grams equals over volume. Whoop, 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 whoop. I got a variable in the denominator, so I'm going to do the Swaparooski. And what that means then is that I end up with volume equals 476.7 over 7.87. So therefore, the volume equals 60.6 milliliters.